definition. I only defined what linear dependence means, but then the opposite of that would be linear independence, right? So I have the definition of the linear independence, which is a list of vectors u1, u2, un is said to be linearly independent, important word here, if the only way a1 times u1 plus a2 times u2 all the way up till an times un equal to 0 holds is if all of the a1, a2, and everything an are 0. That will be exact opposite of linear dependence, right? The only way you can have linear combination of vectors equal to 0 is if all the coefficients are 0. Often in the textbook, this is the first definition you will see. Now, if you just have that definition, it's really hard to know what it means. What it really means is the following. If you have some sequence of numbers, list of numbers, where linear combination gives you 0, and if not all of them are 0, then you can take, say this is non-zero. Then you can take this, put it on the other side, and divide by negative a2. And what you've done is you've expressed u2 as linear combination of u1, u3 until un. Right? You see my point? If a2 is non-zero, then you can say negative a2 u2 is equal to a1 u1 plus a3 u3 plus an un. So the a2 u2 is brought to the other side, and then you divide everything by negative a2, which after canceling you've expressed u2 as negative a1 over a2 u1 minus or this plus negative a3 over a2 u3 plus negative a4 over a2 u4 all the way until negative an over a2 un. So what did you achieve? You've achieved rewriting u2 as a linear combination of the other vectors. That would mean linear dependence, right? Yeah. So this is exactly the thing that we want to avoid. We say u1 through un are linearly independent if there's no way you can have a non-zero and still satisfy this. Because if that's true, then you've represented one vector as a linear combination of the other. That makes the list redundant. We want a non-redundant list. That's basically the idea of the linear independence. Is that okay?